Hello and welcome back. Sean here, Mountains Garage, on an overcast day at the end of January 2024. January is almost in the mirror already. Wow. It was just New Year's, it seems, yesterday. Today, and a little bit last night, I started the assembly process of my Dart LS Ilmore Racing, former 396, soon to be 440 cubic inch project. There's a few other videos if you haven't seen them, bringing me this far. And since we last talked, after I mocked everything up and was pleasantly surprised that everything seemed to fit. For a engine with a longer stroke and whatnot, a lot of times you run into clearance problems along the pan rail for the connecting rod, and especially the rod bolts to clear, and the deck height and everything else. This, for a bunch of junk I actually bought on eBay, I'm pleasantly surprised. The only fault I can find with the whole lower end is I have a little bit, maybe a thousandth or two extra piston to wall clearance, but where it's headed, twin turbo, probably on gas to start anyway, but it could be methanol. I don't think that extra thousandths or two is going to really make a difference. Again, I am programmed to, focus on whatever's wrong and fix it. So even on my own stuff, if it's 99% right, I'm going to fixate on the 1% that's not perfect. But that's good, especially if you're an engine assembler. I'm not an engine builder. I don't have a lot of equipment to actually machine engines. In another life, perhaps, but not today. But I can assemble. It's one of my favorite things. So when you buy a short block and it comes in a bag or whatever, it doesn't look like you get much for your money. But when you spread the internal pieces apart, times 8, all across 4 benches around me here, it takes up a lot of space. And once you get it spread out, I like to get it all back in one spot that I can throw a bag over. So before I had some cutting and grinding I wanted to do on another project. Before I did that, I figured I better stick the short block together, because at some point you get tired of looking and measuring and cleaning, and you're just going to stuff it together and accept the outcome. So you've measured, you've made all your choices, you've determined it's in the range of acceptable, and at some point you're down to proper assembly practices. I've mentioned many times that I am not a big fan of repetition. The thought of putting 7 more pistons in, I've got 1 in so far. It took me most of the day to get all my tools out and my assembly process correct. I had to make a tool, what we're going to cover here in a minute. And, well, I didn't have to, but it sure made life easier. To finally get 1 piston in is easy. I used to break it up. I remember when I was working at the dealership, I always seemed to have a big block Chevy in the corner. And, break time, I'd put 1 or 2 pistons in it. Lunchtime, I'd put a couple pistons in it. And it broke up the monotony once you get all the stuff out. And so that's where we're at today. Now, last night I put the crank in it. So, again, I'm tired of cleaning it and rubbing on it. So the Dart block takes special main bearings. So I had the King X bearings. They're actually black colored, and I happen to have a set of rod bearings to match, also black. I have lots of your traditional silver colored ones of different materials and performance ratings. I'm not sure in the end it really matters for something that should never touch anything, right? In theory, oil is between the bearing and whatever it's next to. So in theory, they really should never touch. So what the bearing made out of, again, that comes down to theory. But the King bearings are really nice, and the black ones, they say racing on them, so they must be good. But they're special for the Dart block and super expensive. And of course you can buy standard or plus a thousandth extra clearance. I went ahead, I had to guess, you gotta get a set of bearings to measure, you can look up the specs in a book of the shell thickness and try to determine it that way. But in the end, you got to put them in the block and with the dial bore gauge determine, or however you're going to determine your bearing clearance. So I went with the standard bearings instead of the +1. I'm glad I did, because I'm a strong 3 1/4 thousandths clearance. It's going to be a dry sump. I can turn it up and put as much oil through it as I want. I'm going to make more windage, but it's going to be nice. The expense of the dry sump, I wasn't thrilled about at first. But when I think about all the potential benefits of it, I can heat the oil tank. I can pre-lube the motor with a drill by taking the belt off the pump. It has lots of advantages, and I can put as much oil through the motor as I want to. So I've never had a dry sump before, but I'm now excited about it. I just got to eventually... I probably won't buy a used one. There's a lot of used ones out there, and they're about half of a new one. So I'll probably just suck that up and buy the new one, and I have to contemplate whether I want the fuel pump in the back of it. You run a mechanical pump right off the dry sump pump. So I got more things to figure out in that area, but the bearings I was happy with, and I put them in. My clearance was good. Rod bearing clearance is good. So I was ready to put together. I put the crank in. The middle 3 caps are splayed, so you put the inner studs in because it's all has ARP studs, and the billet caps, you can see them. And so I put 1 and 5 on first because they're straight. Put all 4 studs in each one, wrist tight. Load up the bearings. I just have some Permatex Ultra Slick. I'm reading the bottle. Assembly lube, red stuff. It hangs on really good. I like it. I recently started working on my 377 small block from a year and a half ago, and I'm sure as I'm rotating the motor that assembly lube is still on the bearing. So, this will probably sit for a while as well. So I want something that's going to be there. Again, I'm going to pre-oil it anyway, but moving on. So I set the crank in, it takes a few minutes to put all the studs in because you set the crank in, there's no studs in the block, and then depending on the style of cap, front and back, you can just put the studs in, set the cap down, and the register's tight, so you actually got to carefully tap it down without knocking the shell out. You just got to be careful what you're doing. I got a flashlight right there. I always make sure when it's down that the bearings are lined up so they'll have the proper crush, because they can cock a little bit. So it pays to be a little bit fussy, even though you're using a hammer. And everything main bearing related is just wrist tight. I will torque everything when I'm done. And as I put each one on to tighten it, I of course spin the crank a little bit, make sure it still spins. Right now, even with 1 piston in it, I don't need the ratchet. I'm surprised that's not falling down. It turns relatively easy. The Molly pistons that I bought came with a ring package, and the wrist pin is up into the oil ring area, so it has a support ring itself, so there's an extra gap you have to measure, so the file fit. So I did the math. There's lots of recommendations about what fuel and what power adder you have, times your bore size. Long story short, I went with 30-30. There's a lot of information about running the top ring a couple thousandths smaller gap, and the second one slightly larger. I just went 30-30. Again, it's 4185. So it didn't take much to file it. I only file one side of the ring. You're supposed to go in an inward direction. I used to, when I first did my first set of file fit rings a long time ago, I would put the ring in there and just squeeze both sides and crank the hell out of it. And I've learned a lot. So if you do a really good job, make sure it's perfectly square, sneak up on it. It takes forever. What I found is I only had to do the top and the second ring. The oil expander rings were fine. They got 15 thousandths or more, which 15 is the minimum. So I was good there. And the support for the piston pin, in the piston pin area of the oil ring, that had plenty of gap. That's actually got a 1/4 inch of gap. It fits a large variety of bore sizes. So in a short time, this is a just a cheap squaring tool that came with something I got. Maybe it came with this, I don't remember. It might have come with the ring filer, but it's got this little protrusions and it's, you know, expandable to fit different bores. You just set it down in there and measure. I measure 12 o'clock, but you could, I've turned it and checked it in several positions. It shouldn't matter that much, only an inch down in the bore, but. So I don't, again, monotony is not my thing, so I'm doing one cylinder at a time, so I cut the rings for it, filed them all up, and they were ready to go. But then things got kind of difficult. My thumbs are still hurting. The piston pin locks, different piston manufacturers have different styles. I looked at these and said, oh boy, these are easy. Well, when you look at them, you almost think they're too big even for the hole. They're way bigger than the pin. And trying to put them in, especially with the pin up where it is in relation to the piston, this portion of the piston, I messed with the first one. I usually, without the pin in there, I put one side in, and then I, figure out which way the connecting rod has to go, slide it all together, put the other side in. I fought and fought with that and thought, there's no way I'm going to get 16, and I'll be crippled in my hands for months trying to get that stupid little ring in there. And then if I launch it across the shop and lose it, I'm going to have to buy more. I've only got 16 of them. So, what to do? Thinking about it, I have lots of scrap metal. I got a lathe. Why am I fighting it? So, I whittled up this rig, which fits the end of the pin. Not doing a very good job showing it to you, yeah? So it fits in the end of the pin. And I used a roll pin, drilled a hole, put it through, ground it so it just cleared the piston. I left it sticking out of both sides thinking it might help. In reality, I could cheat it over a little bit because I'm a little bit smaller than the opening. But what it does, believe it or not, you put the pin in there to locate it, put the lock in right about there. I put the opening at about 3 o'clock. Put it in there and turn it, and it pops it right in there. I did the first one right before lunch today. After I made the tool, it took me 15 to 20 minutes to make the tool. I thought, well, this thing probably won't even work, but I got to try something. It's replacing what I'm trying to do with my finger, and the ability to locate in the pin just made it easy, and it's captive with the roll pin. That and my thumbs on the other side, and I was able to put the first one right together. So that works out. I figured I'd have to build 3 or 4 of them until I got one that would work. So again, just a piece of 7/8 aluminum, machined it down, 590 thousandths, whatever fit inside the pin, 200 thousandths hole with a roll pin in it that I got in an assortment at Harbor Freight. Once again, Harbor Freight providing race engine technology and tools. You'd be surprised. You look through the pits of really expensive cars like at the races, and a lot of Harbor Freight stuff out there. Used to be Craftsman, now it's Harbor Freight. For assembly lube, I already mentioned I put this on the bearings. Good stuff. Just on the the surface near the crankshaft. That's it. For the threads, I had enough of the ARP lube in a cap to a paint can, spray paint can. I saved those for putting miscellaneous liquids or whatnot in. So, and a little paintbrush. So when I put all the main studs together, I used the rest of that. I have more in tubes around here, but I recently asked my brother, who used to be a Detroit diesel mechanic, if he had any of this stuff. This is what you see the top fuel teams using on everything. They call it peanut butter. This is an old can, but it still works. And that's what I'm now using on the connecting rod, bolts, etc. Put a little engine oil on the pin, the wrist pin, and with a paintbrush, I paint a little engine oil on the rings. Funny story, again, don't want to go putting on airs here, but with my fancy assembly techniques, but I was at the transfer station the other day. That's a fancy name for the dump. And the attendant, who I'm friends with because I go there a couple times a week, and He comes walking over with 2 well-worn quarts of oil. They've probably been rattling around in somebody's truck or toolbox for a long time, but they've never been open. You can barely read what they are. One's 530, the other one is Valvoline Max Life. And the Valvoline Max Life got the nod, and that's what I'm wiping on the rings and everything. It's surprising, like, they warn you against dipping the whole. I used to always just dip it in oil. It would make kind of a mess. And I had gone to just painting it, because they want you to put lube on the top and bottom of the ring, but not as much on the sides. Seems to me it's going to wipe off by the time I start it, but they claim it might affect your break-in. I don't know. If you think about how long an engine can sit, and probably if it'll turn, it'll run, I'm not going to worry about a little oil. In fact, I'd rather have it than not have it. But the experts tell you, probably if I built it and put it on the dyno this afternoon, maybe by the time I rotate this many, many times, put it in the car, have to turn it over to bolt up the torque converter, everything else is going to happen, I probably have worn out most of the oil in the cylinder. I do take some on these paper shop rags. I got these back when I was working at the Chrysler dealership in the mid-80s. I've got one package left, I think. It was in my toolbox. They don't lint. They don't leave lint. So you oil this down and rub the cylinder wall. You'd be surprised how dirty these come out, even if you think the bore is clean. So it can't hurt for sure. You know, get that break-in grit out of there. You have to be careful. A lot of rod bearings are not marked upper and lower. These particular king bearings are. If you read the shell on the back, they're marked upper and lower. They're ugly looking for sure, but it's supposed to be good stuff. But they do have an upper and a lower marked on them, so be it. I was somewhat surprised, but it is the way it is. Most of your locking tabs and your bearings typically line up together, like this one does, the connecting rod does. But in the block, they're opposite, which is interesting in my mind. But speaking back to the main bearings, I didn't talk about the thrust. LS thrust bearings are known to be somewhat weak. They're smaller, not much smaller than a small block Chevy, definitely smaller than a big block Chevy. They're located in a different spot in the middle of the engine. The king bearing has lots of extra grooves to help oil it by the looks of it. Again, they don't give any paperwork to tell you that, but looking at it, because there's modifications that can be done. Some people file the actual bearing, cutting a little groove where the halves go together to help get more oil out on the thrust surface. But that kind of takes away those pieces are supposed to touch to have, to squish the bearing together. If you file that away, that's not going to happen. So I thought about it and decided to not do anything in that area and spend my time. I've done videos on, again, making sure the hub in your torque converter slides. You have to pull the converter out of the pump, 1/8 minimum to 3/16 maximum. I like to go about halfway, about 140, 50 thousandths is about right. That way you're good on either side. And make sure beyond that you can slam that thing a 1/2 inch up toward the flex plate. The torque converter needs to move, so you don't want to have a problem there, which I think that's where most of your thrust issues come from. Beyond that, if I was to have the thought of giving it more protection, and I probably will, most likely I'm going to run a Turbo 400. And it's just like a mechanical fuel injection, like a high-speed lean-out jet, but it is a pressure regulator, but it has a pill in it, or an adjustable pill, and you put it in your lower cool line, and you dump it back to the governor cover, or somewhere in the pan, and you can adjust that. You need to tap into that circuit so you can set it for about 70 or 80 pounds, whatever they recommend or whatever you want, because when you assemble the transmission, you're potentially restricting the fill side of the converter, but this is regulating the output. So, I mean, it's connected, it's hydraulic, so it's a circle. And you can set it to stay at a certain temp. Like I'm going to buy mine from Hutch, John Hutchinson, I think his name is. He's Hutch's Transmission Service. I think he's out of Canada. He's one of the guys that I certainly look up to. He is no nonsense. He's always helping people. Definitely knows his stuff. Well regarded, and he sells on his website parts. So I've never spoke to him. Don't know him. Wouldn't mind knowing him, but I'm going to buy one of his regulators and plumb it in line on the converter charge outlet, which is your lower cool line. So that, more than anything, more than modifying my thrust bearing, probably, and making sure my converter slides in and out of the back of the crankshaft, probably more important than cutting my bearings. So if I do all this and still have a problem, well, then I'll have to look elsewhere. But setting up the crank, you look for whatever the spec is, 5 to 7 thousandths of thrust. This, with the assembly lube in it, you can hardly detect any. Without it, I might have had 3 to 4 thousandths, and I'm okay with that. I mean, the crankshaft turns fine. I'd rather start on the tight side. And through all this whole video and everything I do, I'm not an expert at anything. If you want to believe what I'm telling you, which I'm telling you what I know, right or wrong. The way I've always done it, what's worked for me. And again, I don't build engines for a living, but I guess with enough equipment I could. So if you choose to follow my advice, great. If not, use it as one of your guideposts along your journey. So I guess that's it today. Almost time to meet the school bus. I've got all my stuff spread out here, so I got to get 7 more pistons in their holes, but it's a process because, rub on every part, make sure it's, going together to the best of your ability. And again, accept the outcome. So have a nice afternoon and evening, and I'll talk to you later.